In the last lecture, we have studied the registers of 8085. Now here if you see the internal diagram, this is the data bus. Now for this WZ are the two temporary register, 8-bit temporary registers used for the internal operations of 8085. And B, C, D, E, HL are the general purpose register. So each you can use it as a 8-bit register, or if you wanted to use as a pair, B, C, D, E, HL, you can use it as a pair. And these are the general purpose register which will use it for holding the data. Now stack pointer, which will hold the address of the top of the stack, and a program counter which points the address of the next executable instruction. Now increment decrement address latch, which will increment and decrement the registers like a stack pointer and a program counter, and also hold the address. Now this address latch, again here if you see, address buffer 8-bit buffer here and data address buffer 8-bit buffer here. So now here, wherever the buffer and register, if I say, those are nothing but what? Flip-flops are connected. 8-bit means what? 8 flip-flops are connected. 16-bit means what? 16 flip-flops are connected to store the data. Now this I will explain later. Now coming to the instruction register. Now if a processor is fetched the opcode, that opcode will be loaded into the instruction register. So after that, it will send the opcode to the instruction decoder. So it will decode the opcode, and then depending upon that, it will generate the machine cycles. Now again, it will connect it to the timing and control signal. What is this? I will explain later. Now again, coming to the accumulator. Accumulator is also one of the 8-bit register. Through this, we are applying the operand to the ALU. ALU is the arithmetic and logical unit, which is the heart of the microprocessor. And one of the operand we are sending through the temporary register. Now this temporary register is the internal register of the 8085. This is not for the user. So whenever the data is needed, if 2 operands are required for the ALU, one of the operand we have to store it in accumulator. One more operand, it may be in the memory location or it may be in any one of the register. That will be, before going to apply it to the ALU, that will be moved into the temporary register, and after that it will be given to the arithmetic ALU. Now this is about the ALU and accumulator, and after completing the process, again result will be stored into the accumulator, and the flag register will give the status of the ALU or accumulator. Now these are the registers we have studied in the last lecture. Now we will study the remaining. Now here if you see that total it is having the 16-bit address. If that 16-bit address is divided into A0 to A7 is the lower order address, and A8 to A15 is the higher order address. Now this lower order address is multiplexed with the data bus or data lines. So now here if you see AD0 to AD7 means what? Address and data both are multiplexed together. And in this 8085, 8 pins are used for the both address and also data. So whenever the microprocessor generate the address, first that address is loaded into these buffers. Now this is used as a address buffer as well as the data buffer for the lower order. Now the address is loaded here, and that address will be placed on this bus, and it will go to the memory, and memory location will be selected. Once the memory location is selected, again this bus will act like a data bus. Now whatever the data is there, that will be placed again in the same lower order. So now again, once the location is selected, means after that it will act like a data bus. So data will be placed on this bus, and again it will be stored into this data. Now again it will be act like a data buffer. So data will be stored here, and after that through this is also again data bus and to the internal data bus. And after that it will, if it is a opcode, will be placed into the instruction register. If it is a data, it may be placed into the temporary register, or it may be placed into the accumulator or any one of the general purpose register depending upon the instruction what we have given. Now this is about the address buffers and address bus. Now how this address bus is acted like? Now this lower order bus is how it is latched. So how it is acting like address bus and a data bus, that we will see when I'll explain the timing and control signals. Now this is about the address bus. Now coming to the timing and control block. Now here so many pins are connected. Now first we will discuss about the power supply pins. Now here two pins are used for the power supply. One is connected to the plus 5 volts and another one is connected to the ground. And two more pins, X1 and X2 are connected. Now external, these are externally, crystal is connected to these pins so that it will generate the clock. Now after generating the clock, that clock is applied to the ALU and also all the blocks, so that all the blocks are controlled by using the timing signal. So this is nothing but a clock signal. It is given to the all the blocks. Now next one is what? Ready signal. It is coming inside. Means what? Whenever the peripherals are connected to the processor, if data transfer should be taken at the time, if the peripherals are ready or not, that will be indicated by this ready signal. If the peripherals are ready, peripherals will send the ready signal to the processor so that processor will do the data transfer. Now again, this is a read bar. Whenever this pin is equal to 0, then the processor will read the data from the IO devices or from the memory depending upon this pin. If this pin is equal to 1, processor will read the data from the IO. If this pin is equal to 0, processor will read the data from the memory. Now similarly for write operation, if this pin is equal to 0, depending upon this pin, if it is a 1, processor will write the data into the IO. If this pin is equal to 0, then processor will write into the memory. Like that, processor will read, write by using these pins, and to the memory or to the IO by using this pin. Now coming to the ALE. ALE is address latch enable. Now just now I have explained that lower order bits, address bits are multiplexed with the data. Now after decoding, it will generate the machine cycle. Machine cycles is nothing but what? It will generate the clock pulses to do the operation fetching and reading, writing. So for first clock pulse, this ALE bit is 1, so that this address and data bus will be used as a address bus. And after the first clock, again it will go to the 0. Automatically it will go to the 0. Thereby, this address will, thus lower order address data bus will act like a data bus. So this will be done automatically by using this ALE pin. Initially, this will be high. At the beginning, it will be high, and after the first clock pulse, it becomes 0. Thereby, the address and data bus will be acted as a data bus. Now, next two bits are S0 and S1. So, these S0 and S1 bits indicates the status of the microprocessor. If these bits are 0, 0, if these S0 and S1 are 0, 0, then it shows that microprocessor is in the halt position. If this is 0, 0, microprocessor is in halt position. Means what? Not doing anything. So 0, 1 means what? Write operation. 1, 0 means what? Read operation. 1, 1 means what? Fetching is taking place. So depending upon these bits, we can get the information at what is the status of the microprocessor. So this is about the S0 and S1. And already I have explained the IO oblique M bar. Now next one is what? Hold and hold. So DMA signals. So to do the DMA, direct memory accessing, so DMA will send the request signal to the microprocessor by sending the hold signal. So after receiving the hold signal, in response to this hold, processor will send the acknowledgement signal. That is nothing but what? HLDA. Hold acknowledgement signal to the DMA. And after receiving the acknowledgement, microprocessor will give the control on the bus control to the DMA, so that the DMA will do the transfer between IO devices and the memory. So this is about the DMA. Now next coming to the reset bits, reset in and reset out. So reset in means what? By giving the reset in signal, so we can reset the microprocessor. And reset out means what? When the microprocessor is in a reset state, So by sending the reset out signal, the peripherals also, external devices also can be done reset. So this is about the timing and control signal. In that, these are the external devices. These are the external device signal, and the remaining are the few are the timing signals and few are the control signals. Now coming to the interrupt controller. So interrupt control will control the interrupt signals. Now in 8085, total 5 interrupts are there. How many? Total 5 interrupts are there. Those are now whichever having the downwards arrow mark, those are the interrupts. So first one is a trap, which is having the highest priority. And the second one is RST 7.5. And the next one is RST 6.5. And the fourth one is RST 5.5. And the last one is INTR. Now, these are the 5 interrupts in the 8085. These interrupts are controlled by this interrupt controller. After receiving the INTR, so in response to this interrupt, so microprocessor will send the acknowledgement signal to the peripheral. This is the acknowledgement signal. This is not the interrupt. This is the interrupt acknowledgement which is sent by the microprocessor to the peripheral. So now here trap is having the highest priority. Now from the from the top to bottom, it is the priority will change. Now it is having the second and the next priority, and the least priority is INTR. And the trap is also non-maskable. Non-maskable means what? Once the trap signal is generated means what? The processor can't ignore the trap interrupt. Now the remaining all are the maskable interrupt. Depending upon the priority or depending upon the requirement, the processor can neglect the remaining interrupts. So these are all the maskable interrupts. This is the non-maskable interrupt. So these are the interrupts. Now coming to the serial IO control. Now SID, SOD. Serial IO control means what? Within the microprocessor, data transfer takes place in parallel. So 8-bit data means what? At a time, 8 bits will be moved from one register to another register or one block to another block. Now, if the data is from the outside world, if the processor want to send the data to the outside world through the internet cable or to the RS-232 cable, if the data transfer is taking place, that data should be converted into serial. Now, in the unit 1, we have studied the serial input, serial port. So, in that, how the data is converted to parallel to serial and serial to parallel, the same thing is taking place in this serial IO control. So, the data which is received is a parallel. This data will be converted into serial, and this data will be sent to the outside world by using this SOD pin. Now to the internet cable or to the RS-232 cable, it will send the data to the outside, from the processor to the outside by using this SOD pin. Now if the processor is receiving the data from the internet cable or RS-232 cable to the processor, that time it will receive the data from the SID pin, and it will receive the data in serial manner, and in the serial IO controller it will convert the serial data into the parallel, and it will give the data to the 8-bit internal data bus. Now this is about the complete architecture of the 8085.